Sometimes I find for questions to do with similarity that it's better to draw the shapes separately. So that's what I'm going to do here. I've got one of my shapes, which is A, B, C, D, for which the lengths are 6 there and 5 there. And then the larger one, which is an enlargement, which looks something like this, which is A, P, Q, R. Okay, similar shapes, so the angles are all the same. That's 9 there, and that's 12. Okay, so we can do this in various ways. You can see here that the length of BC is 6/9 the length of PQ. So the length of this side, which is the one that we're looking for, CD, must be 6/9 of 12, and 6/9 of 12, well, that's just the same as 2/3 of 12, and 2/3 of 12, or 1/3 of 12 is 4, so 2 times 4, which is 8. Okay, 8 centimeters. Another way that I sometimes like to do these is I can see that corresponding sides are in the same ratio. So if this is the one that I'm looking for, then I know that, for example, x over 6, so that ratio, x over 6, is exactly the same as 12 over 9. Now, if I just now multiply both sides by 6, x must equal 12 times 6 divided by 9. And I can see that everything cancels here. 3 goes into 6 twice, 3 goes into 3. 3 goes into 9, sorry, 3 times. And also the 12 and the 3 becomes 1 and 4. And you're left with 4 times 2, which is 8. And that's another way of thinking of it. Okay, we now want to find the length of AR. Let's call that Y. Okay, again, we can see that y, this time, y is going to have to be multiplied by 9 over 6. Okay, we're going to have to multiply 5 by 9 over 6 to get AR. Okay, instead of 6/9, 5 times 9 over 6. In other words, we're going to have 45 over 6. Or we can divide the top and the bottom by 3 to get 15 over 2. So that must be 7.5. Again, you might prefer to do this using ratios. I can see that y divided by 5, okay, so that side divided by that side must be exactly the same as 9 divided by 6, as long as you do things in the same order. So y over 5 is equal to 9 over 6, and if y over 5 is equal to 9 over 6, I'm going to multiply again by 5. I can see that y is going to be 9 times 5 divided by 6. Again, I can cancel to give my 2 and 3, and I get 15 over 2, which is again 7.5. So that must be 7.5 centimeters. Now we go into areas, which is a little bit more tricky, and it's easier to think here of scale factors. And the scale factor for length that takes us from the small quadrilateral to the big quadrilateral is just 9 over 6. And 9 over 6, in other words, the length on the new one divided by the length on the old, 9 over 6 is the same as 3 over 2. Okay, so what we normally say is that the length scale factor is 3 over 2, or if you like, 1.5. Now, if the length scale factor is 1.5, the area scale factor is always the length scale factor squared. In other words, we're going to do 1.5 squared, so that's an equals, and 1.5 squared, or 3 over 2 squared, comes out as 9 over 4. In other words, 2.25. That means that all of the areas have to be multiplied by 2.25. So in other words, the area of this shape is 2.25 times the area of this shape. Now, they tell us that the area of ABCD is 32, so the area of that one is 32. So the area of this one must be 32 times 2.25. And if you work out 32 times 2.25, or 32 times 9 over 4, 4 and the 32 becomes 1 and 8. In other words, the area of this one must be 72 square centimeters. Now, that means that the area of this big outside quadrilateral is 72, and that's all of this. The area of this bit is, just this bit alone, is 32, which means that the area of this part here must be 72, take away 32. In other words, 40 square centimeters. So that shaded area is actually 40 square centimeters.